Somebody asked how you can answer a question like number 4b here that's asking about an absolute minimum and absolute maximum if you don't have the function f. Here we're given the function f prime, but we're not given the function f. So I would say that because we're asked here for an absolute minimum on a closed interval, those are giveaways that you're going to want to use the candidates test. But you're right that you're not going to be able to get a good satisfactory answer for exactly which number is bigger. But we're going to convince ourselves, we're going to be able to know which one is bigger, but we're not going to be able to know exactly what the number is. So the candidates test says we're going to need to look at all of the critical points and the endpoints. So we're going to need to compare the values at endpoints, which are x equals -1 and x equals 5. Those are the two endpoints we have. And then also at any critical points. For us, the critical points are at x equals 1 and x equals 4, because that's when f prime is equal to 0. So at x equals 1 and x equals 4, f prime is equal to 0. I would argue that we can actually toss out x equals 1, because at x equals 1, f prime does not change sign. F prime is 0, but it doesn't change sign. So there's neither a max or a min at x equals 1. So for our candidates, I'm going to cross off x equals 1 as a possible candidate because I know it's not a max or a min, because f prime does not change sign. But I am going to look at the other candidates. So my x coordinates, and I'm actually going to give myself a little more space here because I know I'm going to need it. I've got my x coordinates, and then I need to know my f of x value. The candidates that I'm looking at are -1, 4, and 5. Okay. And again, you're right, I don't know f, but I do know because of the first part of the fundamental theorem of calculus. I know that if I do the integral from 2 to x of f prime, and I'm going to use t here so that I don't have too many x's for it to make sense, that would equal f of x minus f of 2. Because f is an antiderivative of f prime. And the reason I chose 2 is because I know that f of 2 is equal to 6. So if I ever want to know what f of x is, then I just need to take the integral from 2 to x of f prime and add 6 to it. So this is a formula for giving me f even though I don't know it. So then now I'm going to look at f of -1. F of -1 would be the integral from 2 to -1 of f prime plus 6. But I hate seeing integrals backwards like that, so I would say, well, that's the same thing as the opposite of the integral from -1 to 2. And from -1 to 2, if I look at that on the graph, all of my area is below the x-axis. So this integral would be negative, but I'm going to change the sign on it. So I know that the value of this would be bigger than 6. It's going to be probably quite a bit bigger than 6 because this area is all below the x-axis, but we're going to change the sign on it and then add 6. So we're going to have a number that's bigger than 6. Okay, now I'm going to look at the integral from 2, oops, I wanted to change to red here because we're on a different line. So we're going to look at the integral from 2 to 4 of f prime plus 6. this integral, in a handy way, is above the x-axis. In the correct order, from 2 to 4. So if I look at from 2 to 4 here, I have all this area, but it's all below the x-axis. So I know that this value would be less than 6. I also know that this is a minimum. And I know that this is a minimum because there's a change in sign on f prime. At x equals 4, f prime changes from negative to positive. So there's a minimum at f of 4 is a minimum. Now I'm going to look at 5. If I do the integral from, I'm actually going to break up this integral. I'm going to do, what I notice is that this section that I'm shading here is going to be equal to 0. Because there's area that's above and below the x-axis that is equal. So if I do this integral, if I go from 2 to 3, and then I do the integral from 3 to 5, and then I add 6. I know that this part is 0. I know that this part is less than 0, so I know that the value of f at 5 is going to be less than 6. I also know that there's a maximum at 5. I know that it's bigger than, I also know that it's bigger than f of 4 because I was increasing up to that point. So if I put these in order, I know that x equals f of 4 would be the smallest value I have, f of 5 would be the next smallest, and f of -1 would be the largest value I have. So I can now answer the question, at what value of x does f attain its absolute minimum? The answer to that question is x equals 4. That's actually the only minimum on that interval, so that you could justify with the mean value theorem. The first derivative test, not mean value theorem. And then, at what value of x does f attain its absolute maximum value? There are 2 maxes, but only one is larger than 6, so that's going to be x equals -1 would be the answer to that part of the question. Okay, I hope that helps.